Now example 2. If f from R to R be given by fx equals to mod x for all x belongs to R, is this mapping injective? The question is, you have to check that the mapping is injective or not. So now look at that. The definition of the function is fx equals to mod x. So f2 equal to what? Put x equal to 2 here. So what happened? Mod 2. So mod of 2 means 2. And for f of minus 2, that means mod of minus 2, that is equals to 2. Thus the different elements minus 2 comma 2 of R, that means this R is a domain of f, this domain f, got it? So thus the different elements minus 2 comma 2 of R, domain of f, have same images in R, that is this R is the codomain of f and the image is 2. So different elements minus 2 2 have the same image 2. So if it's not injective according to the definition. Diagrammatically, look at that. This is a curve of fx equals to mod x. Got it? So now, what is the image of 2? Under f is f2. That means 2. Got it? And image of minus 2 is what? f2. F minus 2. Whose image is 2. Got it? So these two are equal. For 2, image is 2. For minus 2, the image is also 2. So these two images are equal. Got it? That's why it is not an injective function. Now, problem 3 or example 3. Let f from R to R be given by fx equals to 2x cube minus 1. Is this mapping in 1 to 1 or injective? How? Look at that. Clearly the domain of f is R. Got it? R to R function, so domain is R. So if we take two arbitrary elements x comma y of R, this is the domain, and assume that fx equals to fy according to the definition of injective functions. So now fx equals to fy, that means 2x cube minus 1 equal to 2y cube minus 1. This minus 1 cancel out, 2 cancel out, so x cube equals to y cube. Now x cube equals to y cube, this implies x minus y into x square plus xy plus y square equal to 0. So either this one equal to 0 implies x equals to y, or this one equal to 0. Got it? So for this x square plus xy plus y square equal to 0, we get imaginary values. Got it? So we reject this value, this equation. So what do we get? Just x equal to y. Thus we see that if x equals to fy implies x equals to y for all xy belong to R. This shows that f is injective. Now this is example number 4. The problem says that show that the function f from q to q defined by fx equal to 3x minus 2 is 1 to 1. How to show it? Let fx equals to fy where xy belong to q, that q is the domain. So fx equal to what? 3x minus 2. So 3x minus 2 equal to 3y minus 2. 2 minus 2 cancel out. So 3x equal to 3y, x equals to y. Thus we see that fx equals to fy implies x equals to y for all xy belong to q. This shows that it's injective function or a one-to-one function. This is a procedure. So now example 5. Show that the signum function f from R to R defined by fx equal to 1 if x greater than 0, equal to 0 if x equal to 0, and minus 1 if x less than 0 is not injective. That means you have to show that this function is not injective. So how to show it? So look at that here, x greater than 0, fx value of fx is what? 1. So look at that, f1, I think this one is greater than 0. So if x greater than 0, fx equal to 1, so f of 1 is 1. And also f of 2 equal to 1 because this 2 is greater than 0. So look at that, this 1 and 2 are different whose images are equal. This is 1 and 1. Thus the different elements 1 and 2 of R, that means domain of F, have same images in R, that is 1, that 1. So if it's not injective. Now show that the function, next problem, show that the function f from R to R defined by fx equal to sin x is not injective. How? Look at the curve of f sin x. This is the curve of sin x. What is the f0? f0 is 0 and f pi is 0. So 0 not equal to pi but 0 equal to 0. That means what? Since f0 equal to sin 0, that is equal to 0, and f pi equal to sin pi, that is equal to 0. So thus the different elements 0 and pi of R, that is domain, have same images in R. That same image is what? 0. That means 0 maps to 0, pi maps to 0. Got it? So 0 and pi are the different elements of the domain. Thus if it's not injective. So our next topic is surjective function or onto function. What's the definition? A mapping F from A to B is called an onto mapping or a surjective mapping if every element in B has at least one pre-image in A. That means if you consider any element in the codomain set B, you have at least one pre-image in A. So now alternative definition is what? F from A to B, the mapping is called a mapping of A onto B. That means a surjective mapping if the image set of A under F is equal to its codomain B. That means this one, fx such that x belongs to, this means what? Image set of F, got it, is equal to B. So image set or range set is equal to the codomain, then if in a mapping image set or range set is equal to the codomain, then the mapping is also called a surjective mapping. Got it? So now note, thus if F from A to B is a surjective mapping, then corresponding to every element y belong to B, there exists at least one element x belong to A such that fx equals to y holds. Got it? So now consider this figure. So F is a mapping from A to B. A has element A, B, C, D, E, and B has element x, y, z. Look at that. A goes to x, B goes to y, C goes to also y, D goes to z, E goes to z. So what is the image of A under F is what? X. So pre-image of x under F is A. Got it? Since image of A under F is x, so pre-image of x under F is A. So x has at least one pre-image. Exactly one pre-image here. So now for y, what is the image of B under F is y. Image of C under F, y. So y has two pre-images B and C. At least one is there. So it is a surjective mapping. Look at that. So Z, what is the pre-image of Z? D and E. So look at that. All so Z has also at least one pre-image. So that means all elements in the codomain have at least one pre-image in the domain. Got it? That's why this mapping is a surjective mapping. Got it? For example, look at that. Let A equal to 2, 3, 4, 5, 6 and B equal to 5, 8, 11, 14, 17 and F from A to B be given by fx equal to 3x minus 1 for all x. Show that F is an onto mapping or surjective mapping. So what happened? Fx equal to 3x minus 1. So F2 equal to how much? 3 into 2 minus 1, that is equal to 5. F3 8, F4 11, F5 14. Similarly, F6 equal to what? 17. So now diagrammatically see that. A to B. A has 2, 3, 4, 5, 6. How many? 5 elements. So his images are 5, 8, 11, 14, 17. So all elements in the codomain have at least one pre-image. 5 has at least one pre-image, 8 has at least one pre-image, 11 has at least one pre-image, 14 has at least one pre-image, 17 has at least one pre-image. So all elements in the codomain has at least one pre-image in the domain. So that's why we see that every element of the codomain B has at least one pre-image in A. Hence, it is a surjective mapping. So alternative procedure is what? Look at that. We see that range of F equal to how much? 5, 8, 11, 14, 17 and that is equal to B. Look at that. What is your B set? 5, 8, 11, 14, 17. That means your codomain. What is your codomain? This one is a codomain. So codomain and range should be equal here. That's why it's a surjective mapping. Thank you so much.